Good morning, Pre-Calc 11 students. Today we're going to carry on with Unit 3, Lesson 4, Factoring Special Trinomials. This is a very important thing for when we go into solving quadratics, especially for something called completing the square. So this is in your note package if you're following along and still doing that. And here we go. So the first thing to notice is, what do you notice about these two binomials? They're the same, right? So let's go ahead and use distributive law to show what happens when we have two identical binomials forming a product. So 2x times 2x is 4x squared. 2x multiplied by positive 6 is going to give us positive 12x. 6 times 2x is going to give us another 12x. And 6 times 6 is going to give us a positive 36. And then the next step for distributive law, of course, is to group these like terms. What do you notice about these like terms? They're the same. So it becomes 4x squared plus 24x plus 36. So again, when we're doing this type of manipulation, we are using distributive law or arrow method or FOIL, whatever you want to call it. But really what we're doing is we're expanding. This is the exact same thing as this. It's just a different way of looking at it. And when we manipulate something to look at it differently, it allows us to do interesting things with it. Okay, so I want you to notice a couple of things. This first term here was created by this term and this term. So they were exactly the same thing being multiplied together, right? Which means that they were squared. So if I want to go the opposite way, if I take the square root of that first term, it's going to give me the first term in the brackets. Okay, and what do you notice about this last term? It was created by the last terms in both binomials be multiplied together, and they're the same number. So 6 times 6 is the same thing as 6 squared. So if we wanted to get the second term in the brackets, we would just take the square root of 36, and we would get 6. Now, if it was negative 6 times negative 6, it would still be positive 36. And if it was positive 6 times positive 6, it would be positive 36. So how we know what symbol goes into both those binomials is we look at this symbol here. So because this is a positive 12x and a positive 12x combined to a positive 24x, it means that they were both positive 6s. And there we go. We have factored that special trinomial without having to use decomp method or finding any magic numbers. And again, when we go from the trinomial to the factored form, of course, we are doing factoring. So we factor. Didn't give myself enough space to write that. So the only key to doing this, which is awesome and much faster than any of those other methods, is you have to recognize whether it is a perfect square. So there's a couple things to look at, okay? So this right here, this term here has to be a perfect square, not just the number, but the variables as well. So the variable, the exponent on the variable has to be an even number. X squared, x to the power 4, x to the power 6, those are all perfect squares. All right. This last term here also has to be a perfect square. And if it has a variable with it, in this case it didn't, but if it had like y's with it, it would have to be y squared. The variables as well have to be have to be perfect squares. All right, so the thing that is the extra check is this middle term, okay? So if we take the square root of the first term, of this first term, 4x, which we did, we got 2x, right? And when we took the square root of this last term, we got 6. To double check that this is a perfect square, we have to go 2x times 6, which is 12x, and we have to multiply it by 2. Because remember, there was 2 terms that were grouped together. So then we multiply it by 2, and we get 24x. Is that what the middle term is? Yes. So that's why we know we can do that. I mean, of course, we knew this one was a perfect square because we did the foiling first, but let's do some practice at determining whether the following are perfect squares. All right, so before you do any work, you kind of want to make sure it's a perfect square. What is the square root of 9x squared? 3x. What is the square root of 25? It's 5. So we're going to go 3x times 5, which is 15x, and then we're going to times that by 2, and we're going to get 30x. Is that what the middle term is? Don't worry about the sign. It is. So this is a perfect square, which means we can go straight to the factor brackets. We've already figured out what the square root of the first term is. It's 3x, so that goes at the beginning of each bracket. And we've already figured out the square root of 25. That's a multiplier. And it's 5. The only other thing we have to do is determine what is the sign. So this middle term was negative 30, which means that it's going to be negative 5 in both brackets. How can you check that you're right? You can FOIL, all right? So you can use distributive law, you can expand and make sure that you get the same trinomial that you start out with. Okay, pause the video here and try B and C. Okay. First things first, let's go with B. The square root of 25x squared is 5x. The square root of 36y squared is 6y. 5x times 6y is 30xy. If we multiply that by 2, do we get this middle term? Yes. So it's a perfect square, so we can put it straight into our factor bracket. So the 5x goes at the beginning of each bracket, and the 6y goes at the end of each bracket. And the only other thing we have to do is determine the sign for the 6y term. And if we look at this middle term, it's positive, so that means it's positive. Okay. Now we can write this more simplified. So 6x plus, I don't know why I want to make that a 6x, but apparently I really do. I'll get over it. It's okay. So it's a 5x plus 6y times a 5x plus 6y. So it's the same thing as saying 5x plus 6y squared. And then, all right, sound effects are very important. Okay, so the last thing to do is see if you haven't tried it yet, pause the video here and try it now. Okay, so the first thing, square root of that first term is 2x. The square root of that second term is 3, and that last term has to be positive. If that last term was negative, you can't take the square root of it, so it's not a perfect square, and you can't do this, okay? You have to go through decomp method or box method. Okay, so 2x times 3 is going to give us 6x. Is 6x times 2 15x? The answer is no. This is not a perfect square. So you can't use this method, even though it looks so good because it has a perfect square at the front and the perfect square at the end. This middle term is not 12x. Oops. So you cannot factor it with the special trinomial method because it's not special. Sorry, trinomial, not special. So you have to do this one the old school fashioned way. You need two numbers that multiply to 36. And those same two numbers need to add to 15. Okay. And you should get 12 and 3. Just making sure I'm not going off script here. 12 and 3. Okay. So then whatever method you use, decomp or box method, and of course I'm a fan of the box methods, not the box, sorry, I am a fan of decomp. So I'm going to do decomp. 4x squared plus 12x plus 3x plus 9. I'm going to factor out 4x from both these first two terms, leaving me with x plus 3. And then I'm going to factor out the 3, which leaves me with x plus 3. And my factors are x plus 3 times 4x plus 3. And there I be. Okay. And that is the special trinomial where it's a trinomial square. Okay, perfect square trinomial. Hopefully that rang some bells. All right. So this next one here is going to be a different special trinomial. Okay, my favorite. So if you look at these two binomials, they almost look the same, but there's something different about them. You can see what's different. I meant to highlight it with yellow so I could, oh my goodness. All right. So who can see what's different between these? They look almost the same, but they're not. And if you said they have a different sign, Miss Mackenzie, you are so right. So this one's positive and this one's negative. So it's not the same thing as a perfect square trinomial. We're going to use distributive law and expand. If you want to pause the video and do it yourself just to get the practice, please do so. All right, so x squared times x squared is 4x squared. 2x times negative 6 is negative 12x. 6 times 2x is positive 12x. And 6 times negative 6 is negative 36. Okay, and now you have two like terms. So again, you're going to do the same thing. You're going to group your like terms. And what do you notice about them? They're the same, except they have opposite signs. So negative 12x plus 12x or 12x minus 12x cancels out. So the middle terms cancel out and leave you with 4x squared minus 36. And there you go. So we've gone from the factors to the expanded version. So we expanded. And today we're just going to review how you go the opposite way. How do you factor? So what I like about difference of squares, it's very simple to identify. You don't have to check middle term because there is none. Okay, so is this a perfect square? Yes. Okay, that's step one to recognizing it. Is this a perfect square? Yes, that's step 2 for recognizing it. And the only other thing you have to look at, is this a negative? Yes, then it is a difference of squares. Remember, difference is just another way of saying subtraction. So literally this means it's two squares where one's being subtracted from the other. And is that what's happening here? Yes. So to get what the factor brackets are, if you recognize that this is a difference of squares, you take the square root of the first term, which is 2x. You take the square root of the second term, ignoring the sign in this particular case, and I'll show you why in a second. So just take the absolute value of 36, whether it's negative, it's going to be negative. So you take the absolute value of negative 36, so the square root of positive 36 is 6. Okay. And one bracket is going to be positive and the other bracket is going to be negative. It doesn't matter which one you make positive and which one when you make negative, as long as one is positive and one is negative. You can't make them both negative. You can't make them both positive because then that's not a difference of squares. That's a perfect trinomial square. I always like to put my negative in the second bracket in case it's kind of one of these cascading questions that can be further factored later on. I'm going to show you examples of what those look like. All right, so pause the video here and try A, B, and C. Okay, so first of all, you have to recognize or check that is it a difference of squares. The first thing that clues you in is there's only two terms. The second thing you look for, is this a perfect square? Yes. The second thing, is this a perfect square? Yes. And is this negative? Yes. So you go straight to the factor brackets. The square root of 9x squared is 3x. So you put a 3x at the beginning of the first bracket and a 3x at the beginning of the second bracket. And then the next thing you do is you take the absolute value of negative 25, so positive 25, and you square root that. And the answer is 5. So you put a 5 in the first at the end of the first bracket, and you put a 5 at the end of the second bracket. And then because it's difference of squares and we need that middle term to cancel out, one is positive and one is negative. All right, next one. If you haven't tried it, pause it, try it. Welcome back. Okay, so this one is 36 a perfect square? Yes. Is positive 4x squared a perfect square? Yes, square root is 2x. And is the middle, is the symbol on the second term is a negative? You just can't really see it very well. I don't know what that is. But yes, it's a negative. So that means one of these terms has a positive and the second has a negative. Okay. Let's do the next one. So this might look a little freakish, but if it does, if you want, you can do what's called a U substitution, which we're going to cover later. Instead of looking at it like all that stuff in a bracket, just replace it with a U. So U squared minus 25. Is this a perfect square? Or in that, is that a perfect square? Yes. Is the second term a perfect square? Yes. And is the middle or the symbol on the second term a negative? Yes. So this is a difference of squares as well. So in the first bracket, you put the square root of the first term. Now I replaced it with U instead, and that's what I'm going to do. So it'll just be a U, and a U goes in here. I forgot to do a step, but I'll tell you about that later. And then you put the square root of 25 in both brackets of the absolute value of negative 25, so it's going to be 5 and 5. And then because it's difference of squares, one is positive and one is negative. So what I forgot to do is write let U equal x plus 3. I forgot to put my let statement there. It's kind of like a legend. So now we just have to put that x plus 3 back in for where we have U. So here we have U here and here. We had U replace the stuff that was in the brackets because it looks a little too weird for us. So now we're going to put that x plus 3 back in for U. So every place we see U, we're going to put x plus 3 plus 5. And we're going to do that again here, x plus 3 minus 5. And now we can simplify. So x plus 3 plus 5 is the same thing as x plus 8. And this is the same thing as x minus 2, which is not a difference of squares, but it got manipulated into a difference of squares so that we could factor it. I'm going to pause that here. We are going to talk more about U substitutions in the next video, but I want you guys to focus on factoring difference of squares and perfect trinomial squares in that handout that I have attached. Please let me know if you have any questions. I hope that was helpful. Have a great day.